The rest of the lecture we will not talk about declarations, but instead of expressions. And two important parts are precedence and associativity. Precedence says, for instance, that we should multiply before we add. Okay? And so that is, everyone knows already, for almost all operators. And associativity, instead, it is about when we have several operators of the same kind. So, for instance, if we have add, no, but subtract, how is that evaluated? Well, it can either be evaluated from the left to the right or from the right to the left. But the binary operators, they are left associative. So that means it is evaluated as if there was an parenthesis here. But the unary operators and assignment, they, and also conditional expression, they are right associative instead. So that means if we have this, it is, we first evaluate the rightmost one, so it means this. Okay, and here we have a compound assignment. That means an operator and an assignment in one. And it's also right associative, so it's evaluated like this. And what is the value of this? Well, the value of b plus equals c is the new value of b. So if a is 1, b is 10, and c is 100, a will eventually become 111. Okay, more examples. What's the value of this? This is an example of an operator that you perhaps do not know the precedence rules for. We might expect that we should do like this, since in some sense it looks more reasonable, but it's not. It's evaluated like this. And most C programmers have once in their life made a mistake by not knowing this. Okay? But now you will not. Okay? More about evaluation of expressions. If we have operands with a type that is smaller than an int, then they are converted to an int or to an unsigned int, depending on whether the value will fit in an unsigned int, if it will fit in a signed int or not. Okay, so what is the value of this? Well, what happens is that we first change the unsigned car to an int, and then the b to an int, and then divide, so c will be 0. Here we instead convert the 1 to a double, and then, well, of course, during runtime this conversion is not done, but the compiler will produce the code for C plus 1. Okay, and actually you should not view this 1 as a constant in an instruction. Instead, view floating point constants as read-only variables. That's how they are stored. So what happens when we read a constant, an integer constant, it's very easy, it's just part of the instruction. But a floating point constant instead is it contains so many bits, so it cannot be stored in the floating point instruction. There are no constants in floating point instructions. and instead it has to be read from memory, like as if it was a variable, but of course it cannot be changed, the value. Okay, and then this floating point add is performed and the value is written back to this car. So if we actually are disappointed with getting 0 to this, how should we do to get 0.5 instead? This doesn't work since the evaluation is done before the cast. So if we write the type like this, then we convert the expression to a different type. I mean the expression that is to the right of this. It's called a cast. And what we must do is to convert one of the operands, and then it will work. In assignments, we are not allowed to mix the different pointer types, except if we have a void pointer, either as source or destination. Recall, a void pointer is a generic data pointer, but a void pointer is not allowed to point to a function. Because a void pointer, I mean a data pointer and a function pointer, they can have different sizes. So it's not portable. Okay, so what is valid here? We can save an integer pointer into a void pointer, or the other way around. We cannot change, save a long pointer into an integer pointer, or a signed car into just a plain car. There are different types. Okay, and since we can save like this, I mean in this case, there is no need to do like this if we request memory from malloc. In C++ that's necessary, but not in C, since it's permitted to copy from a void pointer to any other data pointer.